Hi, let's take a look at multiplying and dividing with exponents. We have 8 to the 7th times 8 cubed. Our 8s are called our bases. And when the bases are the same, you can simply add the exponents when you multiply. So this means that we really have 7 8s, 1, 2, 3, 4, 5, 6, 7, times 3 8s, 1, 2, 3. How many do we have all together? Well, we keep our base. It's the same base, so we keep that base of 8, and then we simply add the exponents. 7 plus 3 is 10. But you can count the 8s, 1, 2, 3, 4, 5, 6, 7. There's 7 8s and 3 8s, 8, 9, 10, and you get the same thing. So this is expanded. You can put the little multiplication dots here. So repeated multiplication of the same number, you can write that with exponent notation. Let's take a look at another problem. Let's say that you had 2 cubed times 2 to the 4th power. Well, if we expanded this, it means we are going to write 3 2s, and it's repeated multiplication. So my 2 is my base, and again, here my 2 is my base, so I have the same base. I'm going to write 4 2s, 1, 2, 3, 4. So how many 2s do I have? 1, 2, 3, 4, 5, 6, 7. So I can write that as 2 to the 7th power. But without expanding it, you just check, you have the same base, so you write your 2, and then you simply add the exponents. 3 plus 4 is 7, and we come out with the same answer. Let's take a look at another problem. You can actually do the same thing with numbers or variables. So this problem works with variables. So we have a to the 4th power times a cubed. Our a's are our bases, the small numbers are exponent. So I know that I can just, since either the same base, I know I can just add the exponent. So this is going to be a to the 7th power. But if I wanted to expand it, it means I have 4 a's, 1, 2, 3, 4, times 3 a's. So 1, 2, 3. How many do I have all together? A to the 7th. Let's take a look at another one. This time I have x to the 8th power times x cubed. Well, I'm missing an exponent right here. Every number and every variable has an exponent, and this one is hidden, so it's understood that there is a 1 here. So again, the x is all the same base, x, and so all I have to do is simply add the exponent. So 8 plus 1 is 9, and 9 plus 3 is 12. So it would be x to the 12th power. Let's take a look at another one. This time we're going to change it a little bit, and I'm going to have 2m to the 4th times 5m. So let's start with our numbers. I have a 2 and a 5. They're different. They're not the same base. So all I can do is multiply them. So 2 times 5 is 10. And now, let's take a look at the m's. They are the same base. So I'm going to write my m down. I have 4 here, and then there's an understood 1 right here. So I simply add those two exponents together, and that would give me 10m to the 5th power, and that's actually the answer. Let's take a look at another one. Okay, in this problem, my 3 and my 7 are not the same base, so I'm going to multiply them. So 3 times 7 is 21. And now my a's, I'm going to look at those. They're the same base. This one has an exponent of 2. This one is an 11. So focusing on my a's, I'm just going to add the exponents together, the 2 and the 11, and that's going to give me a to the 13th power. And so here's my final answer, 21a to the 13th power. Let's take a look at another one. This time we have m to the 4th times m to the 0 power. All right, m to the 0 power. That's interesting. So let me show you how this works. Let's say that we had 2/3 to the 0 power. It would equal 1. Let's say we had 99 to the 0 power. It would equal 1. So anything to the 0 power is going to equal 1. So we can substitute. We can keep our m to the 4th power. And we said m to the 0 power equals 1, so times 1. So m to the 4th times 1 would be just m to the fourth. Okay, well let's change this just a little bit. Let's say that we had m to the fourth times m. Well, this time, remember, there's no exponent, but there's really an invisible understood exponent of a 1. So I'm going to keep my same base of m, and then the rule is that if it's the same base, I can simply add the exponents, and so that would give me m to the fifth power. Let's take a look at dividing with exponents. Okay, let's take a look at division with exponents. When you have the same bases, the rule is that you simply subtract the exponents. When you multiplied same bases, you added the exponents. Well, when you divide same bases, you're going to do the opposite. You're going to subtract the exponents. But let's go ahead and expand this. So on top I have 6 sevens, 1, 2, 3, 4, 5, 6. And on bottom I have 2 sevens, 1, 2. And these cancel out. 7 over 7 is 1, and 7 over 7 is 1. And so 1 times 1 times the 4 sevens would just be 7 to the fourth power. And that would be over 1 because there's a 1 on the bottom. And to write this a little bit better, I'm just going to erase that 1. We can also take this problem and keep our base, and then simply subtract the exponent. 6 minus 2 is 4, and come up with the same answer. So a very simple rule for division with same bases. Let's take a look at another problem. So we're dividing again. We're dividing the same bases. We have 8 ends on top and 3 ends on the bottom. So the rule is that you can simply subtract the exponents. So I've got 8 ends on top, 4, 5, 6, 7, 8, and I've got 3 ends on bottom. If we expand this, that makes 1, 1, and 1, and so that leaves me 1, 2, 3, 4, 5 ends on top. So my answer would be n to the fifth power. And again, the rule is if you divide bases, the same bases, all you have to do is subtract the exponents. So you can think about it like n to the 8 minus 3, which would be n to the fifth power. Let's take a look at another problem. Alright, this one's a little bit more complicated. So we have 4 and 10, they're not the same bases. And we have m to the ninth power and m to the second power, and those are the same bases. So first let's take a look at our numbers. So if we think about 4 over 10, we know that these are both even numbers and they're divisible by 2. So if I simplified the 4 and the 10, I would get 2 on top and a 5 on the bottom. Alright, so I've taken care of my numbers, and now let's look at the m's. I've got 9 m's on top and 2 m's on bottom, so I've got more m's on top. So I know that my answer for my m variable is going to go on top in the numerator. So if I follow the rule, I simply subtract the exponents. We said the m is going to be in the numerator, and 9 minus 2 is 7, and that's the answer. Let's take a look at another one. In this problem, there's a couple of ways that you can do it. What I'm going to do is focus on just the numerator for right now. So I have 12 as the coefficient in front of this variable, and then in front of the second y, the y to the 8th power, I also have a coefficient. There's an understood 1 right there. So I'm going to multiply my numbers. 12 times 1 is 12. Okay, now I'm going to look at the y's. The y's are the same base, so because they're the same base, I can simply add the exponents. So we have 2 plus 8, so I'm going to add my y here. And then 2 plus 8 is 10, so that would be 12y to the 10th power for my numerator. And then my denominator, I'm going to go ahead and bring that over. Now, we have numbers that are both even and they're divisible by 4. So if I simplify this and I divided the 12 by 4 and the 16 by 4, 12 divided by 4 is 3 and 16 divided by 4 is 4. And now I'm going to look at my y's. They're the same base, so the rule is I subtract the exponents. I have more y's on top, so I know that my y answer is going to remain in the numerator. And 10 minus 3 is 7, and that's the answer to that. Let's take a look at one more problem. Alright, in this problem I have m to the 5th times n to the 0 power over 2m. So, the first thing I want to do is I want to focus in on this n to the 0 power. Earlier in the video I told you that any number or variable to the 0 power simply means 1. So really I've got m to the 5th times 1 on top in my numerator, and so I can write that better in the numerator because m to the 5th times 1 is just m to the 5th. So this is what the problem really looks like. And now I'm just going to simplify it. So my 2 is going to remain in the denominator. I've got 1m on the bottom with an understood exponent of 1. They're dividing same basis, so I subtract the exponents. So I've got more m's on the top, so my answer is going to remain in the numerator, and 5 minus 1 is 4. And so that's the answer, m to the 4th power over 2. Thank you so much for watching my video. Check out my others online.